All right, so orbital mechanics 101. Um, just ahead of time, I have been sick, so if I cough, I apologize. You've been warned. In Outer Wilds, everything has gravitational pull. In this diagram, we can actually see gravitational pull as alpha here. It's pulling the object closer to the center of the body right here. And our velocity is tangential. Well, what does tangential mean? Well, it means that it's perpendicular to the surface of the circle at any point. So you see, v is a representation of the tangential velocity. Now, we've been talking about how slow is fast and fast is slow. What we mean by that is that in order to change orbits, circular orbits, like this, make it smaller, we actually have to slow down. And what slowing down actually allows us to do is it allows us to fall from this orbit into this orbit. Okay? And you'll notice here that in order to gravitational pull is inversely proportional to distance squared, meaning that the closer you are, the much stronger gravity is. Okay? So in order to travel around a planet in a circular orbit, you have to be traveling much faster the closer you are. So if we wanted to catch up to the sun station, if we imagine that the sun station is this planet or this body that is circling on the purple line, we have to enter orbit behind the object at a lower distance to the main body or the sun to catch up. And once we catch up, we actually have to raise our orbit, which means we need to speed up. Now, speeding up when it raises our orbit will actually put us in a higher orbit, and it'll either be higher than this purple one or it'll be matching this purple one if we're close enough to the sun station that we'll actually be at the sun station by the time we've matched velocities with the sun station. So let's give you a representation of what that looks like. So we're going to catch up to the sun station here. And we're going to enter orbit around the sun behind the sun station. And we got to start slowing down because we're traveling way too fast. So I'm just going to kind of work it so that we can get into orbit around it. So I'm going to pull back and slow down. And I'm trying to not get sucked into the sun as well, simultaneously. So there we are, we're starting to catch up. Just remember, we gotta be in a lower orbit. Speed up. So we've been in the lower orbit for a little while now. So we're speeding up. We're catching up to the sun station. Want to maintain that lower orbit. And once we get to the sun station, now we have to speed up a little bit. And we'll slow down once we catch up. Now we're basically at the same orbit as the sun station. Now things start to get a little bit weird when you get inside the sun station because you get into the game's influence of the sun station. But that's alright. But that's basically what we mean. Now, if we experiment a little bit and say we slow down, well, we'll actually enter a lower orbit just like we did right there. We don't want to fall into the sun, so we're going to speed back up. And now, if we speed up, well, let's get back to where we were. Now, if we're in the middle of the sun station and we decide, well, we're going to speed up, well, we're going to change orbits, and we're actually going to get thrown away from the sun station at the same time as we're slowing down. So that's what we mean. Slow is fast, and fast is slow. Um, know it's kind of a lot, but hopefully you get the idea.